Hey guys, let's do a third electric fields problem. 2-point particles with charges Q1 and Q2 are separated by a distance L as shown below. The electric field at point A is 0, which is a distance L over 3 from Q1. Determine the ratio Q1 to Q2. Okay, so this is the diagram we've been given in the picture. So here we have A. A is a distance of L over 3 from Q1. Q1 is a distance of L from Q2. We have to figure out the ratio Q1 to Q2. Now, a key piece of information in this question is that the electric field at point A is 0. Okay, and based on that, we're going to already make a mathematical expression to try and solve from that starting point. Okay, so the electric field at A is 0. So why don't we take a look at A? Let's zoom in on A for a bit. Okay, so right here at A, we know that Q1 and Q2, they're given the same charge. Okay, so they're both going to be positive, or let them even both be negative. It doesn't matter. They would still have similar behavior. Let's assume Q1 and Q2 were positive. In that case, the electric field lines from Q1 would be going outward. So due to Q1, it would be going in this direction, the electric field, and due to Q2, the electric field would be going in the opposite direction. This is the case where Q1 and Q2 are positive. Now, since they don't tell us whether they're positive or negative, assume also the case scenario where they are negative. Okay, just to put your mind at ease that this works in both cases. Okay, so in the case where Q1 and Q2 are negative, therefore, the electric field lines should be going in towards Q1 and in towards Q2, which means now this direction would be the electric field due to 2. This would be the electric field due to 1. But notice that in both cases, the magnitudes of the two electric fields have to be equal. They're still opposite in direction, but the magnitudes are equal. So let it be this case or this case, it doesn't matter. Okay, but we know that based on these pictures, EA is 0, and we also know that E1 has to be set equal to E2. Okay? Now, the expression for the electric field for E1 is equal to E2 is KQ over R squared. Now, because this is E1, it's going to be KQ1 over R1 squared. E2 will be KQ2 over R2 squared. So we've already got a nice simplification there. We can cancel out the K's and replace it with a 1. Now, we're looking for the ratio Q1 to Q2. So what I'm going to end up doing is dividing Q2 on the right and the left and multiplying both sides by R1 squared. Okay, so bring the Q2 down, bring the R1 squared up. So you'll get Q1 over Q2, there's your ratio, equals R1 over R2 squared. So all I did there is take the square outside of the bracket. So at this point, I need expressions for R1 and R2. R1 is the distance from Q1 to the point of interest, which is A. R2 is the distance from Q2 to the point of interest, or A. Okay, so this is going to be my R2. This is my R1. Now notice R1 is already given to us. It's L over 3. So all that's left for us to determine is R2. Okay, so R1 is L over 3. And notice based on the picture, R1 plus R2 equals L. Okay, so based on that, we can say that R2 is L minus R1. Or R2 is equal to L minus L over 3. So essentially what you have here is 1L minus a third of an L, which is 2/3 of an L. Okay, so R2 is equal to, R2 is 2/3 L. So we're going to plug that into the expression over here. So R1 over R2. So R1 is L over 3. R2 is 2L over 3. And this whole thing is squared. Now, because I have an L in both numerators, the way you should think about it is this. If you divide a fraction by a fraction, essentially what you're doing is, let me rewrite this. Let's continue the math over here. Okay, essentially what you're doing is saying L over 3, you take the fraction in the denominator, you flip it, and you multiply it to the fraction in the numerator. So this will be times 3 over 2L, and this still is being squared. So based on this, you can more easily see that the L's are going to cancel, the 3's are going to cancel, and you're going to be left simply with 1 over 2. So therefore, Q1 over Q2 is going to be equal to 1/2. Now remember, that's being squared. 1/2 squared is a quarter. So therefore, Q1 over Q2 is equal to 1 over 4. And that's it for this problem, guys. I hope you enjoyed it. If you did, be sure to smash that like button and subscribe to Physics in the Flesh so you never miss a video from me. Stay tuned next week at 12 noon for video 158. Alright guys, that's it for this video. I hope you enjoyed it. If you did, be sure to smash that like button so I know what I'm doing makes sense to you guys. And you know how you can stay tuned for my latest videos? By subscribing to Physics in the Flesh. I post every weekday at 12 noon, and this way you guys can always be the first to know when I post a new video. As always, guys, thank you so much for watching. If you missed any of my earlier videos, be sure to click over there on the right. You can click and watch those videos on your screen right now. Anyways, guys, Physics in the Flesh out. Woo-hoo! Holy crap, my nose looks big on camera. I gotta find a new angle.